Hey everyone, and welcome back. Before you watch this walkthrough, make sure that you pause the video and try the problem yourself. Even a partial attempt will make the explanation that much more useful. These videos are meant to support your problem-solving process, not replace it. Across a lot of my practice problems, I highlight different aspects of how to approach, break down, and reason through problems. So you're going to get the best benefit by watching multiple walkthroughs rather than treating any single one of my videos as a template that you can copy. With that, let's get started. Today's practice problem is going to be about modeling objects within objects. We're going to be looking at modeling a player and their weapon. Imagine that we're going to create a player class and that a player has a weapon. Each of these classes should be able to describe themselves, and the player should be able to attack using their weapon. We're going to jump right into our code. In this video, we're really going to see where Java stops feeling like a pile of variables and start feeling like an actual real system. Let's get started by creating two classes. First, we need to consider our player. Now, when we're looking at our player, we need to understand that a player can have something like a name. And we also need to understand that it's going to be able to have a weapon. Now, a weapon is going to be an object that we will pass in through the constructor, and then we'll be able to call methods across our object boundaries. This is introducing a very important idea in object-oriented design, and it's that objects don't copy each other, they hold references to each other. It's important for us to understand that each of these different classes are responsible for their own information, and the other class won't really know anything about it. For example, the weapon class doesn't need to know the player's name. Imagine if a sword knew your name. That would make it very sentient. And the player doesn't really need to know how the sword is constructed, right? It doesn't need to know how the sword is going to attack. The player just needs to know that the sword can be attacked with. This brings us to a really important idea known as single responsibility. Each class is only responsible for its own information, and it can go and ask other classes for information about those objects. Let's get our weapon in here. Now, like we said, we're going to be able to get that weapon information in from our constructor. So if we have a constructor public player, we understand that when a new player enters a game, they can set their name. They can also tell us what weapon they'd like to hold. So let's get those pieces set up here, and then we're going to pause and work on our weapon class. Is equal to weapon. Oops. All right. Let's pause here just for a second, and let's make our next class. I'm going to go ahead and open up my side view here. I'm also going to split my screen in half so that we can see more than one of our classes at a time. So on this side, we'll do our public class weapon. Now, what is it that we want our weapon to be able to do? Well, I guess a weapon can have a type or a name, like a sword or a mace or a wand, private string type. And we're also going to have it so that it can deal some kind of damage. That's good enough. I wasn't going to do like damage total or something, but damage is probably sufficient. So let's go ahead and save this as a weapon.java class. And let's also make sure that we can set this up with constructors as well. We will have a string type and the damage that can be inflicted. Now, these are both private, which means we are now going to, in order to get information about these, need to write some methods to help us get this information out. Let me just finish up my constructor here. This dot damage will be the damage. And let's ask ourselves, what is it that a weapon can do? Well, we should understand that a weapon can deal damage, and dealing damage basically means that the damage is coming out of the weapon. So let's go ahead and make a method called deal damage that will do exactly that. We can get exactly how much damage, a weapon can do. As part of deal damage, we could also maybe print something out or, give more information here. Alternatively, we can just make ourselves a toString toString, and this will just give us the information we need about a given weapon. So we can return a formatted string that says this weapon is and it'll be like a sword or a wand or something like that, and does some amount, oops, that's supposed to be a percent sign, sorry, some amount of damage points. It's kind of a long line for right here, I know. We'll do our %n there. I will move this over for a sec so that we can see a bit more all at once. Whoops. There we go. And I will also make this just a little bit smaller so we can see all of it. Now we can go ahead and add our two parameters. So we're going to have the type and the damage. All right. Now, before we continue sort of connecting these classes together, we've now written some functional methods here, things that actually do stuff. So we should probably test those. And in order to test them, we are going to need a main method and a main class. So I'll go ahead and make one more class. I'll just put it on this side for now. Main. And here I can do a test. Let's do main.java as our save. We'll get our main, and let's make a weapon. A weapon sword. We'll make a new weapon, and into that constructor, let's pass in the word sword, since it is a sword, and some amount of damage it can do. We'll pass in, let's say 15 damage. I don't know, relative, I don't know how much damage that is. Let's do one more. We'll do a really big sword this time, because I'm really creative, as we can tell. And here we'll say giant sword. And our damage will be double. It's double damage compared to just a regular sword. And now in order to make sure that these do what we expect, we could return from deal damage. We can also just print the information out from both of them and make sure that one tells us it's a sword that does 15 damage. Whoops. And the other one will be a really big sword that does 30 damage. Really big sword. Awesome. All right, let's go ahead and compile our code. Make sure that we didn't make any mistakes around that. Make sure that we have these two different types of swords. Oh, we should make sure we're in the right folder. There are my 3 Java files, among other random things on my desktop. And now we can go ahead and we can run our main and make sure that we actually get out of it what we expect. Okay, check that out. Oh no, something is wrong, right? I accidentally used the conversion, the formatting specifier F. I needed to have used D. I can go find the line that it's on. If I follow my stack trace here and I look for not a Java base class, I find it's at weapon in my toString method on line 15. I come right over here and I find it there. I can go ahead and change that to a D. I've changed my code. I can go ahead and recompile. I'll get all that out of the way and rerun. I now see that this weapon is a sword and does 15 damage points as I expect, and this weapon is a giant sword and does 30 damage points, just as I expect. Awesome. Now let's get our player class actually doing something. Well, the easiest first step is to also write our toString over here. Public string toString. Now, what will our toString be over here? Well, we need to make sure that we say our name. Oops, I am player, whatever your name is going to be. And I can spell, and I am holding a weapon. And then we can do this weapon is a sword and does blank damage points as well. So we can do that with another %s and then a new line. Oh, and then that should be good enough actually. All right. And now what are our 2 parameters here? Well, we understand that the first %s is going to represent our name, right? I am player blank. So I am player Lauren. Then we have to figure out how we're going to print out the weapon part of this. Well, what we'll do is we will grab our weapon, but specifically we will grab that toString method from our weapon. Now, when we call printline, as we've seen previously, we don't need to write the dot notation, that dot toString, but in a string format call, we do, because this needs to already be in a string form. It cannot be in an object form. Over here in print line, it can be in an object form. So that's why we don't need the dot toString here. Okay, so now we have a player class that will allow us to print out some information about our player. Let's go ahead and create a player. Player 1, I guess. And that's me, Lauren. And I'll start by holding my sword. And I can make sure that everything got set up properly by printing out player 1's information. I'll go ahead and just comment these out so that they're out of our way. And let's go ahead and recompile this down here. Whoops. Recompile and run. I am player Lauren and I'm holding a weapon. This weapon is a sword and does 15 damage points. So it prints out exactly as I'd expect. That's fantastic. Now, as a player, I can't do very much right now. This is a problem. I should be able to attack with my weapon. And if we ask ourselves what else should we be able to do? Well, if we think about it, a player is holding a weapon in their hand. It's not glued to them. It's not part of their body. I should be able to change out my weapon. I should be able to drop my old weapon and pick up a new weapon. Pick up a new weapon. Okay. Let's write these two methods. We can have a public attack method. Public void attack. What happens when we do an attack? Well, we can print out, I attack with my weapon. Or I can even do, I attack with my, and we need a weapon type now. So I should be able to get the weapon type from my weapon. Now, I don't actually have a method that allows me right now to just get the weapon type out. Get type. I'm going to need to go and create this method. It makes sense to have to ask the weapon, what type are you? Because that's the weapon's information. As a human being, you don't always just like walk around with your name on your shirt. Maybe sometimes, but not always. If somebody wants to know your name, they have to ask. That's exactly what we're setting up here. So we'll add a method here, public string get type, that allows us to ask the weapon for what type it is. Return the type of the weapon. So now when I attack, I can say I attack with my whatever weapon type. And I can even add one more thing here that says my weapon dot get weapon type does some amount of damage, right? So we can go and grab that information from our weapon as well. We've already made a deal damage method. So we will do this much damage. All right, at this point, I know that I'm not going to be changing my weapon class very much, so I'm just going to actually recombine my view here just to make it a little bit easier to see everything. Okay, so we can see that I've written my attack method so that system.out.println, I'll attack with my weapon, and then my weapon of whatever type, oh, I'm going to need brackets there, will do some amount of damage. There we go. All right, in order to test this, I should come over here and actually call the player 1. Player 1 is going to attack. And as we know, based on what we just saw, player 1.attack should call the attack method for the player. So let's hop in and see. It should print out, I attack with my, grab the weapon I'm holding and get its type from it, sword in this case, and then system.out.println, my sword does, grab the damage amount, 15 damage. Let's go ahead and compile this and make sure it does what we intend. No compile time errors, awesome. And let's go ahead and run it. Right here is my attack part. I attack with my sword. My sword does 15 damage. So that actually worked beautifully, exactly what we expected. Let's comment this one out for a second. The last thing we want to test and write is this idea of being able to pick up a new weapon. Now, in the real world, in order to pick up a new weapon in its most literal form, I need to put down the old weapon and then pick up a new one. Thankfully, we don't have to do that in Java. Java will allow us to just sort of assign a new weapon to the player's hand, and it's understood that the old weapon isn't there anymore. So let's go ahead and do that. Public void pick up weapon. And in order to pick up a weapon, we need to pass in some kind of weapon that we want to pick up. And now all we need to do is assign the hand that's holding the weapon to the new weapon that's coming in. And we can pick up a new weapon like this. So now, for example, if I flip back over to main and player 1 realizes, oh, there's a really big sword over here. Pick up new, what did I call it? That's not the name of it. Pick up weapon. Not having IntelliSense is sometimes frustrating, but it's mostly okay. There we go. We can pick up our really big sword, and then we can try to attack with that instead. So now what I'm expecting is line 11 here should still print out, I attack with my sword does 15 damage. When I pick up my new weapon, nothing prints out. But then when I attack, I should now be attacking with my new weapon. So it should say I attack with my giant sword, and my sword does 30 damage. So I should get both printing out. Let's go ahead and clear this, recompile, and see if it works. There we go. And as we can see, we are printing out both. I attack with my sword does 15 damage. I attack with my giant sword does 30 damage. Now, I want to draw your attention before we finish up to just a few things that I did here. I made sure that the weapon was in charge of the weapon's properties and the player was in charge of the player's properties. Now, the player does have a weapon, but that doesn't automatically give them access to all of the insides of a weapon, right? The weapon is still responsible for its own fields and values. It's very similar to you owning your own laptop. And while you have access to the interface that is the keyboard and the monitor, you can't immediately just grab all the insides from your computer. You have to go through the monitor to see it. You have to go through the keyboard and your mouse to gain access. That's what we're doing here. Our player class is gaining access through the weapon's interface, through the weapon saying, I can tell you about what type of weapon I am. I can tell you what kind of damage I can do. So we're getting access to all of that, but it's also still hidden away very nicely within a weapons class. I'm also not giving access to anything that I shouldn't be. If we look at our weapons class here, you'll notice that there's no way for me to change the type of the weapon because this isn't a magical weapon class. I can't say I was a sword and now I'm a machete. If it's a sword, it's forever a sword. And if we want to make a different type of weapon, we'd have to actually go and say, oh, we found a different type of weapon that we want to use. There's no way to redesignate an old type of weapon as a machete now. Now, at this point in the course, it might seem like this is silly and there isn't a really big difference. So why really require the use of the new keyword? Why not just make a method that lets me change the name of the machete or of the object to machete and change the damage of the object to 10. Well, there is a reason for that, but it is a little bit complex and comes later. For now, we just want to ask ourselves, what makes sense in the real world? Can I be holding a sword and just tell it, now it's a machete? Now it's a wand? No, I can't. So it makes sense to actually have multiple objects rather than just resetting the variables within a given object. And we really want to keep trying to relate these objects back to what would be feasible in the real world around you as much as possible. It's going to help us organize our code a lot better. That's really all there is to this question. We're seeing how classes can contain other classes to create this has a composition relationship. We can see that we can pass objects into constructors or in methods. We can also see that we're passing objects around by their reference and that we can delegate behavior of objects to the object that makes the most sense. That's it. And now we've solved this problem. Now remember, you won't find my solution posted alongside this video. If you watch the walkthrough without first attempting the problem, stop here, close my solution, and try to write it yourself now. Post-walkthrough practice still counts. If you have questions about this problem or suggestions for future practice videos, please be sure to leave them in the comment section below. Thanks everyone, and I'll see you next time. Bye.